Okay. Hey, everybody. Welcome to our chat by the digital fireside. We've got Christina Medved, who might be familiar to many of you, past Leaf Pack, or in our first, weren't you our first Leaf Pack network administrator? And
Yes.
Ash. And then we have Dr. Bernard Sweeney, who is of many, many things, past director, executive director of the Stroud Water Research Center, past president, and so much more. And also was the one who created the Leaf Pack Network. So we thought we would do a wonderful time with both of these Leaf Pack superstars, chatting about history of Leaf Pack and sharing some of the amazing stories that have happened in, like the first couple of decades of Leaf Pack, if not beyond, with all of you. So hang tight. This is going to be a really exciting time together. And I'm going to pop up. We're going to hear first from Dr. Bernard Sweeney, and then we'll hear from Christina Medved. So we're going to pop to a presentation here. All right, can y'all see this?
Yeah.
Take it away, Bern.
Okay, so hi, I'm Bernard Sweeney, and I was going to talk a little bit about the evolution of LeafPack as a multi-purpose tool, a tool for research, a tool for monitoring, and a tool for education. Next slide. So LeafPack as a tool for research had its birthplace at the Stroud Water Research Center in the late 1960s. Next slide. It really was the brainchild of Robin Van Oot, who was the first director of the Stroud Water Research Center. He is really the inventor of LeafPack. He was undergoing some significant studies on the White Clay Creek stream ecosystem at the Stroud Water Research Center. And next slide. And he quickly realized that the leaves falling into a stream in the fall from the surrounding forest was an extremely important food resource for the stream and river ecosystem. Next slide. He was able to quantify the amount of leaf litter that was getting into the stream for the very first time anywhere in the world. And to his surprise, he found out that the bottom of a stream often had 5 to 10 times the amount of leaves than were actually on the banks of the stream in the floodplain next to it. Next slide. And his studies showed that these leaves would float a little bit downstream and then catch behind rocks in the bottom of the stream and form these really thick leaf packs. And lo and behold, when he investigated those leaf packs, he would find that they were very quickly being colonized by a whole wide variety of macrovertebrate species. Next slide. And these macroinvertebrates were voraciously eating the leaves. So it became quickly obvious that leaf litter was an important food resource. A lot of animals in the stream were recognizing it as such and were taking advantage of it and eating it. Next slide. He, in a report that he filed in 1969, which was a report on his ongoing studies of the White Clay Creek ecosystem to the Rockefeller Foundation, who was funding it. Next slide. He in that report describes the very first leaf pack that was put together anywhere in the world. Now he assembled the leaf pack and weighed it out, tied it together with monofilament, and then put it in the stream and anchored it in the stream at that time by tying it to bricks. Next slide. So this is actually a photo that he took of a leaf pack in the stream that he made, tied to that brick that you see, that sort of brick with the holes in it. And this is the way he put these in the stream to actually try to figure out what was going on with these leaf packs. Next slide. Well, after about 6 months of intensive study, he realized that not only were these things being colonized by a wide variety of insects, but some species were becoming very abundant. And through time, they were living and growing inside these leaf packs. They were getting bigger because they were eating the leaves and using it as food. Next slide. He then explored various experimental work to try to figure out whether the macroinvertebrates could actually tell one leaf from another and whether it was important to them in terms of how well they could grow. Next slide. And what he found was that indeed, the macroinvertebrates could tell one leaf type from another, and that the ones they preferred to eat, they actually grew best on. So they could really tell the leaves apart, and the ones that they felt were nutritionally valuable, they were preferring to eat those, and they were doing well on them. Next slide. So the leaf pack as a research tool was born at that moment. Around 1969, Robin went to some scientific meetings, I think out in Michigan, and presented his paper about how he was working with these leaf packs and how it was giving him great insights into how the stream ecosystem worked. And that triggered a whole litany of papers, not only the following year, but for the following decades, on using leaf pack as a research tool to understand how the stream and river ecosystem worked. Well, about 1983, next slide, Robin Van Oot and I, we were working on a project in South Carolina at the Savannah River site. And next slide, the Savannah River site was a place where the United States produces all the plutonium and tritium for their nuclear weapons. But they were having an issue down there because in the process of producing these raw materials for nuclear weapons, they would cause the streams and rivers on that experimental site to go up and down almost on a daily basis. In other words, they would be flood stage and then they would be just a base flow. Then there would be flood stage and base flow, sometimes for a couple of days. And they were nervous that it was impacting the stream, and they hired the Stroud Water Research Center to take a look at it and to do some experimental work. Next slide. So as part of our experimental work, trying to figure out whether or not the flow fluctuations were having an impact on the system down there in South Carolina, we decided to use leaf packs to try to figure it out. And in this case, instead of tying the leaf packs to rocks, because there are no rocks in South Carolina streams, they're coastal plain streams and they're all sandy, we put leaves in a mesh onion bag that we bought at the food market. And we put those onion bags containing leaves out into the stream. Next slide. So this is a photo of myself on the left and Robin Van Oot, who has his back to you with the hat on, actually in a stream there called Upper Three Runs, placing the leaf packs in these mesh bags into the stream. And this is around 1983, right? Next slide. We would not only put them on the bottom of the stream, but we would tie them onto logs and things that were laying in the stream from the banks, or we'd actually put logs in the stream with some of these leaf packs tethered to them. And then we would leave them in there for 3 or 4 weeks to colonize with all the macroinvertebrates. And then we would simulate a flow fluctuation. We'd simulate that particular log that you're looking at, the flow would go down and the leaf packs in that log would be exposed to the air for 8 hours or 10 hours or 24 hours. And we would do that by actually pulling the leaf packs out. Next slide. So these are leaf packs that were in the stream. We would take them out and we would let them hang there for a certain amount of time. And we would try to see what would happen, what macroinvertebrates would crawl out of the leaves and actually leave the leaf pack, or which ones would stay in there, and whether or not they would live or die after so many hours, and so on and so forth. So this leaf pack became a very valuable tool for helping the government at this plant figure out whether they were causing problems with the ecosystem there on the stream ecosystems on the plant. So next slide. So leaf pack as an educational tool was really born in 1990 when the Stroud Water Research Center did an experimental education program with a little nearby school called the Upland Country Day School. And with, in particular, the 9th grade students of that school. It turned out that my daughter was a 9th grade student in that school. Their biology teacher came to me and said, I would like to do an outside field experiment with the students. Do you have anything that we could do? Next slide. So I designed a 9th grade science field experiment for that teacher, and he liked it. And so we decided to do it. And the experiment was to make up leaf packs, some of which had native species of leaves in it, and some of which had non-native leaf species in it. And the hypothesis was that local stream macroinvertebrates would prefer eating leaves from native species of trees that grew nearby than from non-native trees. In other words, they were used to eating the native trees, and they might take a bite out of a non-native tree and go, I don't like this. I've never seen this before. I don't want to do this. That was the hypothesis. And so next slide, we did the experiment. With the students and the teacher and all, they made the leaf packs up in the onion bags like we saw in the previous thing I was talking about. And we put them in a small stream near the Stroud Water Research Center. We left them in there for about 4 or 5 weeks. And then they came as a class assignment, recovered the leaf packs, took them back to their school, opened them up, and counted the number of macroinvertebrates in each of the different leaf packs. And then worked up the data as to how many macroinvertebrates they found in the leaf packs that have native species of leaves in it and how many in the non-native species of leaves. And it turned out that there really were a lot more macroinvertebrates in the native species of leaves. So next slide. And the kids loved the experiment. The feedback from the teacher was they loved doing this. And so on or about that time, 1991, we started a formal education program targeting middle school and high school students at the Stroud Water Research Center. So we were actually looking for things to go out and attract high school teachers to let us bring them to the Stroud Center and do experimental work with them. And the leaf pack experiment was one of the very first things that we sort of marketed to those teachers. We said, hey, we have this program, and wouldn't it be great if you came and had your class do this here? And our experience is that the students really liked this program, and they did, and it was a highly successful program. Next slide. And so shortly thereafter, like a year later, we approached a commercial company, Lamont Chemical Company, and asked them if they would be interested in producing a leaf pack experiment stream ecology kit for us. And you can see this is what the kit looked like, that they helped design it. We co-designed it, and they produced it. And then we had a canned education program that we could actually make available to any school teacher in the United States, and eventually within a year or two throughout the world. Next slide. So that's kind of like the how this thing got going. Once we had the commercial leaf pack kits available, teachers began doing it all across the country. At that point, we started something called the Leaf Pack Network, and that was a network that connected all the teachers across the country and throughout the world that were doing our leaf pack program. And they could share their data with one another. They could discuss pros and cons of the project. They could bring up new innovations they were bringing to the leaf pack experiment kit, and so on and so forth. And so it all started from one little 9th grade class experiment, and within about 5 years, it exploded into this big national, international kind of program. And next slide. And that's sort of like the evolution of leaf pack from a research tool to a research and monitoring tool, and then eventually to an educational tool. And that's sort of the nuts and bolts of it.
So Tara, I think that if it's okay with you, I think what I have for a PowerPoint will dovetail perfectly into like where Bern just ended. If you want us to go there, or if you want us to ask Bern some questions.
No, that's fine. Go ahead. Yeah.
Okay. So, hi everybody. My name is Christina Medved. I worked at the Stroud Water Research Center from 2001 to 2014. And I was as Tara mentioned, the very first Leaf Pack Network administrator. And it was in 2001, I think Bern, at that time, Stroud scientists were already working on monitoring New York City's drinking water supply. And so in addition to the scientists conducting a 7 or 8 year study, we also received a grant to provide a tremendous amount of education programs within the New York City drinking water supply watershed. So mostly up in the Catskill Mountains and then also in Westchester County. So LeafPack, from what I remember, really hit the ground running once we started that project. And so what ended up happening is the other educators at Stroud and myself spent a lot of time in the Catskill Mountains educating teachers up there how to use the LeafPack experiment as a tool for them to monitor and assess their local rivers at the same time that the Stroud scientists were assessing them as well. And we realized, I'm going to fast forward a few years, but it was really great that we had this exposure to work with those teachers and those students. But we also realized in around 2008 or 2009 that we're like, well, we're still not reaching like the 4 million people or so in New York City that are getting this drinking water, and we really wanted to reach them. So we actually, I'm going to start sharing my screen now. We actually, from LeafPack came the Mountain Tap to Tap experiment. I'm sorry, the Mountain Tap to Tap trek, which was a 3-week trek across New York City's water supply system. It was 6 students from New York City, 6 kids from the Catskill Mountains, high school students, and they traveled 200 miles by foot, by boat, having meetings and press conferences and meeting local artists, etc., scientists. And their whole mission was to catalog this journey through photographs and journal entries about what they were seeing about how New York City's drinking water supply was being treated. And at the end, they put together a photography and journal exhibit that was in multiple places in New York City and then also in the Catskill Mountains. They became the educators to the people in New York City about where their drinking water is coming from. So I think that's like one really fun success story of LeafPack and all of the different opportunities that LeafPack brings to teachers and to communities alike. So I'm going to now backtrack it a little bit to 2003-ish or so, when a woman by the name of Wangari Maathai came to visit us at the Stroud Center. And we were just learning about a group that she started in Kenya called the Green Belt Movement. Some of you may have heard of her because it was in 2004 that she actually won the Nobel Peace Prize. But we met her before that, all of that happened, and we learned a lot about what the Green Belt movement was doing in Kenya. And what she had started many years prior was I think it was like a nursery, right? She was teaching women in particular and single mothers how to grow trees so that that could be a source of income for them and their families. And so we gave her a LeafPack kit, and she took it back and gave it to these 3 primary schools. And they did something so beautiful with this program that I had to share with everybody. They said that I'm looking at my notes here because I have a direct quote from them, is they said the LeafPack project involved a sector of society that would ordinarily not participate in the broader conservation debate, which was primary school students. So they actually brought in elders from the community to teach the students about their local rivers and what were their gauges for what was a clean river versus a non-clean river. In one of the schools in particular, the elders explained that the river carries the name, which was called the Matundu River. I hope I'm saying that right. The Matundu River is actually a tree. And they said the reason that river is called that is because the trees flourished in the riparian area. And the students started looking around, and they said there was not one Matundu tree in that area. And so again, another success story here is that this inspired the students to restore the original Matundu River by starting a riparian replanting project. And I know that Bern has also done a tremendous amount of research on riparian areas. And I just know, again, it's like a full story coming there. And then we also had so many individual teachers, thanks to Lamont, actually, for continuously bringing us. I think it was every year they invited us to join them at science teacher conferences around the United States. So we had the opportunity to present LeafPack at national science teacher conferences. And from what I recall, I was actually thinking about it this morning, most of the time we're talking national science teacher conferences. Most of the time, we were the only people presenting on stream ecology and looking at aquatic insects for monitoring streams, even though that topic is actually a part of the national science standards. And so we were always really happy to be able to offer teachers some type of curriculum or experiment that they could very easily replicate in the classroom. And it was at one of those conferences that we met a teacher in Oregon by the name of Charlie Graham, and he just ran with leaf pack. So in addition to rearing rainbow trout and Chinook, I think it was some salmon that they had raising in fry in the classroom. The day that they released those fish is when they placed their leaf packs. And so many of you might know that we have control leaf packs and experimental leaf packs. Charlie was the first teacher that ever called me that actually started an experimental leaf pack. And he had said to me, Christina, we have an abundance of Western red cedar, red alder, and big leaf maple, but we have way a lot of Western red cedar. I'm not really sure what to do with it. And I was like, well, there's an opportunity for you to create an experimental leaf pack and see what happens. And so he called me to tell me they were so excited because the pack that had the Western red cedar had a tremendous, he said it was loaded in hydrocycates. I actually have this quote here. He said, way more than the control leaf pack. So this project with Charlie actually, again, blossomed into another program where he started working with a family-owned sustainable forestry practice in Oregon. And that family business talked to Charlie and said, we'd really like to show the world, if you will, that we can harvest trees and still have healthy rivers on our property. And Charlie was like, I know what we need to do leaf pack experiments here because it directly ties in the health of your riparian area with monitoring your rivers and streams. So Bern, you'll be super excited to find out because Tara and I only discovered this earlier this year. 15 years later, they're still using leaf packs at that sustainable forestry practice. So they're called Hyla Woods, located in Oregon. But it's a good news story to be telling people. And I've got more stories. So Bern, you and I ended up going to Peru in 2010 to provide a leaf pack workshop to both teachers and conservation professionals in Iquitos and Pucallpa. And I just want to draw everybody's attention to the picture on the lower left. I don't know if you can see my mouse here, but Bern was inside teaching this program with a entomologist from Florida A&M by the name of Wills Flowers. Our friend Paco Oliveras was there, and Tirani Gonzalez was there with ACER. But Bern was teaching inside, and I happened to walk outside. This is a school in Pucallpa. And I walked outside and there was all of these children and mothers and fathers that were lining the outside of the building because they wanted to hear what we were teaching. And so it was really spectacular because once Bern took all of the actual participants down to the river to do their experiment, I stayed back and got all of our equipment ready. And I don't speak Spanish. I still to this day don't speak Spanish, but I couldn't really communicate with the school children except through using my hands. And so I brought out some markers and some pieces of paper and showed them how to use the brockscopes. And so they were collecting all sorts of insects and plants from the playground there. And we actually ended up making a little art display. And so when everyone came back from the river, there was like a little art project up on the wall from the local students. And it was really sweet. And from what I understand, these organizations are still using leaf packs to assess streams in their areas. And I'm pretty sure that program has grown since then. At least that's my understanding. And then later that same year, we ended up going to Costa Rica, and Rafa, who works for the Stroud Water Research Center at their, I'll just call it the Costa Rica station where they study tropical streams. He ended up joining us, and we ended up seeing like firsthand some of the challenges that conducting a leaf pack experiment in, for example, the mid-Atlantic states brought versus the tropics. So I don't know if the protocol is still like this, but back when I was the leaf pack administrator, if you were conducting a leaf pack experiment in the United States, your control leaf packs would have leaves from the 3 most dominant trees in the riparian area. And I was on this workshop in Costa Rica and like, Christina, look around. We have a lot more than 3. Like, we're going to need to add more and more leaves into these leaf packs. And so it was a really good opportunity for us to start amending leaf pack for use in tropical streams. And we did the same thing in 2008 when we actually brought conservation professionals and scientists from Costa Rica, Guatemala, Peru, Mexico, and the US. It was a 5-day immersion experience for them to help us translate to translate into Spanish the leaf pack manuals, but also that's what really kicked off our adapting leaf pack for use in tropical streams. And then I always like to tell people that if Death Valley National Park can conduct a leaf pack experiment, anybody can conduct a leaf pack experiment. As you all know, the Death Valley National Park in some places is close to 300 feet below sea level. And from what the park rangers told me at the time, they've got 2 streams that they place leaf packs in. You're going to love these names: Salt Creek and Bad Water. And they said that, yes, these names are suitable and imply exactly what kind of rivers they are. But interestingly, they have a fish species there called the pupfish, which I included an image of that here. And they said that they do have invertebrates. They have caddisflies, stoneflies, beetles. They said that these creeks will have some water in them in the spring for about a mile before they disappear in the permeable surfaces. And then once summer hits, and it's 120 degrees out there, these pupfish, the ones that survive, actually end up going into the headwaters, into the springs, right? And sort of like burrow themselves into the sediment there until it starts raining again. So they were able to conduct leaf pack experiments using salt grass and pickleweed. Those are the plants in their riparian area. So again, if Death Valley National Park can conduct a leaf pack experiment, anybody can. And then I was really excited. Actually, this is one of the last big leaf pack projects that I did before I moved to my current job, which is in Colorado, working for another smaller watershed organization in the Rocky Mountains. But I did author an article in American Water Resources Association. They had one issue back then that was all about education. And so it was an exciting opportunity for me to author an article called "Using Slimy Leaves for Stream Water Quality Assessments, the Leaf Peck Experiment." So then again, we had an opportunity to, it's almost like full circle, right? Bern, like it started as a research project. This magazine mostly goes to water resource professionals and researchers. And so to then sort of like bring it all the way back to educating them on how they could use it as research tools with their project partners, et cetera, was really neat. The one thing I'd love to sort of end on is that I think the thing that I find most fascinating about leaf pack is that every stream has a story to tell, as you guys know. And it was when I first started working at Stroud that I was like, oh my gosh, like I had no idea that the riparian area is just as much a part of the river as the water. I still tell people that, right? And it was mostly because of the research that came out of the Stroud Center and some of your other colleagues as well. And so to me, it's like there's no better way to determine how healthy your river is than by looking at how healthy your riparian area is, and combining those two is exactly what leaf pack does. And then, Tara will agree, as an instructional tool, it's how clever and innovative and easy for a teacher to provide a stream ecology program without necessarily having to take maybe 8 different classes or 100 students into one section of stream, but actually bringing the stream to the classroom. It's brilliant. Bern, it's brilliant. So bravo to you and Robin and everyone else that's worked on this for so long.
We had no clue it was going to be brilliant. We were using it as a tool. Research, monitoring, and another tool just for education. And it caught on. And sometimes things just catch on the way you don't expect them to catch on. I don't know if you remember, Christine. I don't know if you were with us when we were doing a workshop in Iquitos, Peru, but we had a hike in like 5 miles by foot, carrying batteries so we could do PowerPoint display. And we were in a thatched hut that was pretty big, and the hut was jammed full of the local people. And the workshop was difficult to give because we were doing it in Spanish, which was a second language for us. Spanish was a second language to the local people because they had their own. We were so far inland in the Amazon River basin, they had their own dialect, So Spanish was their second language, and we were thinking, oh, this is not going to go very well, but it went beautifully. But at one point, we thought the whole thing collapsed because the floor of the building actually collapsed in the middle of the workshop. The floor was perched 3 feet above the ground because of the floodwaters during the rainy season in the Amazon. And we had so many people jammed in the workshop that the whole floor collapsed 3 feet. And in the United States, if the workshop site had a floor collapse 3 feet, that would be the end of the workshop. But there, the people were like, no, 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 we want to continue. Let's just take everything outside and do it outside. So we took all the tables outside and we just continued and finished the workshop. It was an amazing experience. It was great. Yeah.
I was there for that. I was
Yeah,
there
it
for
was
that.
it was just like an incredible experience where the educators and the students were so interested that they didn't really care that their building fell apart. They wanted to see the leaf pack experiment, and it was really cool. Yeah.
I think I have, if you don't mind, I'm actually gonna share that slide, Bern, because I think I have a picture of that program you're talking about was funded by the National Geographic Foundation, and the caretakers that were up there had a daughter. And right here, I don't know if you could see that, Bern, but you and Will's Flowers went into the river to just sort of like flip over a couple of rocks and dig into the sediment there. And this little girl, I can't remember her name. She wouldn't leave your side. She was like looking in the bowl more than you were. You were like, you just gave her your tweezers so she can help you, preserve some things. And it was like, it was such a sweet, as you can see, even on this top left picture. I mean, the students it's funny, even to this day, I still teach macroinvertebrate programs, and it doesn't matter how old people are. It could be young, or it could be senior citizens, or everything in between. People love aquatic insects. At first, they're squeamish. Tara knows this so well. It's like, well, I don't really want to look at bugs. Like, I don't really want to look at this. But then they start looking at them, and I always tell people, look in the brockscope. It'll actually look back at you. And they're just like, what? And then they can't stop looking.
Yeah. It's true.
What
I was involved in many, many, many leaf pack experimental education programs, and everybody was always into it. I mean, there was never like, oh, when's this going to be over? It just was like, this is really cool. And so, and you just don't know how that experience for them plays out later in their life. That one-time experience of, understanding streams for what they are. They're important, they're a very important source of fresh water and so on. And how important that is later on when those people go out into the world and become, entrepreneurs and business operators, and how that plays into their mindset. I think you got to catch them when they're young to instill that environmental value in their minds. Yeah. And Leaf Pack does that so well.
Yeah.
Wow,
And Tara knows that, right, Tara?
Yeah.
Well, I was teaching a leaf pack workshop actually just a few days ago on Saturday, gorgeous day here at Stroud, and everyone was so immersed, and it was hard to kind of like peel them away to be like, well, we got, the workshop's supposed to end in like 5 minutes, but we stayed a little longer, and it really feels more holistic and also more respectful of the stream. I share often, because I've seen it from Christina's past slides, it's just about the benefits of leaf pack, and there are so many, just this method, this approach, and it just feels a little bit more respectful and kind to studying the stream. We are gentle with the packs, putting them in the stream. We don't, like Christina said, get hundreds of pairs of boots and shoes in there and disturb the habitat, shaking up every rock and bringing them back. And so that, I love this. And when I was in Georgia, prior to coming to Stroud, I actually was looking up amphibian monitoring methods, because that's what I was doing, and leaf pack came up. So I was using leaf pack to study salamander larvae before I was knowing that it was for, there was this whole leaf pack network program, and I come up here to Stroud and they're like, well, we've got this really neat, package of stream monitoring program. I was like, oh, wow, that's great. And yeah, it just keeps growing and growing. You know, we've did a big facelift in 2020 with the Lamont company, just enhancing some of the parts of it. But the core methods and everything are still there, and it's so exciting, and it keeps continuing on as a really supportive tool. So many teachers around here love it, and it's great to get stories from in the field across, you know, in Bhutan or across the world still. So thank you all so much. Yeah. I didn't know if there's any final remarks or any sharings that you want to do. I know we could probably talk for a long time about many stories that have been inspirational to you both. And
Well, one thing that I neglected to say, and I should say it right now, is that I want to shout out a thank you and to Peter Davenport of the Davenport Foundation. Peter Davenport was a board member of the Stroud Water Research Center at the time when we were inventing leaf pack. And when I said to him, we were thinking about going commercial with it so that somebody could produce it and therefore make it readily available to teachers all across the country and throughout the world. He was very much involved with the Lamont company. And he said, I think Lamont could do this. They might be interested in it. I think they could do it. And he introduced us to Lamont and helped promote the idea with Lamont that this would happen. And it was really a marriage made in heaven from the very outset. We clicked with the Lamont designers and everything. They clicked with us. And within 3 to 4 months, we had the kit designed. I mean, and it
Wow.
really pretty much today what it was at that moment. It just happened so beautifully. And we made, you know, a bunch of us made several trips down into Maryland to the Lamont company to meet with them. And they were just terrific to work for. And that all happened because of Peter Davenport and the Davenport Foundation. And it was, you know, so some things like that just have to come together, you know, to make the whole thing successful. And that was one of the things it did. And who knew it was going to be successful? Nobody. We were just exploring. We're just scientists and educators exploring. And sometimes it works out, and it did work out.
yeah,
I will add to that too, Bern, if it's okay. I was actually just thinking about all of the teachers and other like nature center educators, and thinking about Aaron Bennett up at the like it was a nonprofit group up in the Catskills who, in the very beginning of LeafPack as the educational tool, when I was there, we were still trying to give teachers like tidbits of like, how do you put a leaf pack in the riffle area without it washing away? And, you know, Aaron was really one of the people because he was putting it in these rivers, these mountain rivers that were really fast. That was like experimenting different ways to tie the leaf pack down so that it wouldn't wash down. And so I just keep thinking about all the people that like helped get leaf pack to where it is today, right? Like the people that we don't even know where they're at right now, right? Everyone's like sort of like gone their own way professionally, but like that literally helped get it to where it is today. Like, yay, thank you to all of the leaf pack champions over the years. Like we couldn't have done it without everybody helping us pilot test things, right?
That's why I called my little PowerPoint the evolution of the leaf pack, because it was an evolution and involved a lot of people, and that's the way evolution works. It makes things better. It makes species stronger and so on and so forth. And so leaf pack today is so much better than it was in 1990. And it's the thanks of all the people that did the leaf pack experiments and that took the time to try to pass on little tidbits of information that would make it stronger and better and more successful. And yeah, there's a lot of people out there that we probably have 5 pages of names that we should be mentioning.
Right. And then I think creating not just the experiment itself, but then having the network. I know that so many teachers have told me over the years, like, wow, that really is going to close the whole scientific experiment, the loop for my students, right? That they not just did a project at school, but then they're going to see their data online. And then in those early years, like we were one of the first, by the way, we were one of the Stroud Leaf Pack Network was one of the first websites out there that you can actually compare 2 data sets, right? that wasn't like scientifically based. It was all like educational based. And so it was, teachers were like, oh my gosh, I can actually see what the leaf pack was placed this, November of 2023 to like 2024. Like, oh my gosh, this is going to be so great for my students. And it fulfills so many standards. And like, we couldn't have known that all in the beginning. And here we are, all these years later, and it's still fulfilling all of these standards, right? Because these are all still very important things as part of the scientific process and the scientific method, right?
Right, yeah.
Yeah, and hands-on field-based experiences that have a civic action piece, so many great stories coming out of teachers now that are trying to really engage students in the civic action. So like you get the results from Leaf Pack, now what? And so a lot of students are finding their streams might be poor or fair kind of rating over time, maybe, and now they're questioning, what can we do to improve water quality? Who can we speak to? Who can we write letters to? So yeah, it's been amazing to see those stories being shared. So,
And
well,
remember, Christina, as part of the New York project, you were doing leaf pack up in the Catskill Mountains on all the streams that we were doing our technical work to try to figure out their quality. And we did a whole bunch of experiments that showed a really great correlation between the results of the leaf pack and the results of the really highly technical water quality assessment work that we were doing on each site. In other words, we put some leaf packs in the stream, and with choosing that approach, we got a pretty good idea whether the stream was great, excellent, fair, poor, whatever. I mean, that it was right on the money. And it worked that way in Peru too. And we published a paper on it, basically. Yeah, we published a paper on how leaf pack can give you a really good handle on water quality in a stream in the Central America. It works.
It works.
It works.
And in the meantime, we get to see so many beautiful rivers all over the world.
Isn't that the truth? Yeah.
Yeah.
Oh, well, thank you. This has been such a treat and really, really important to have this all documented too, to share with the world that's interested in leaf pack. And I just want to thank you all so much for your time. For those of you that don't know, we have been trying to do this presentation and gathering for many, many months now. And finally we're able to make our schedules and technology function and work in harmony. So thank you all for your patience. But it's so great to see you both in the same kind of screen also. So much history, and yeah, the legacy continues. Thank you both so much for being the sparks of that.
Thanks for putting it together, Tara.
Yeah, thank you, Tara. Thank you, Tara. And thank you, Bern.
Yeah. So bye, everybody.